What should we do first? Yeah, that's more than one full rotation. So rather than just subtract that 360, we can divide by 360. So 1282014 divided by 360, and that's writing 2 thick. So let's go smaller, and that should give us what? What information would that give us? Right, that's going to be the number of rotations. So the real trick to doing this problem is just to make sure that you have everything typed in very, very correctly. It's real easy maybe to put like an extra 1 in the front or something. Did I do that? Yeah, see? Okay, so you could have the idea down, the right procedure, but then just mistype or something. So 1282014. I think that this warm-up was originally created on January 28th, 2014. I believe that's where this number comes from. So if that's the case, we're 2 years and about 9 days ahead of schedule. Wow. Go us, right? All right, so we're going to divide by 360. You might imagine then what tomorrow's angle might be if I keep that going. That's going to give us 3,561 full rotations and then 1/1500ths of another. Do we really care about the full 3561 rotations? No. So instead of just typing in 0.15, rather I encourage you to just subtract, in this case, the number of full rotations in the case that it's not a terminating decimal. In this case, it is. So that's the fraction of a rotation. All right, so what I'll do on my iPad here just to show the procedure, and again, this is not necessarily something you have to do on a multiple choice, but if we subtract that out, we get 0.15 of a rotation. And if I remultiply that by 360 to get the number of degrees that rotation is, we get 54 degrees. Now, 54 degrees is a very important number because what do we call that angle? That's the reference angle. Yes, very good. But before, bless you, before it's the reference angle, it's actually the what? It's actually good. It's actually the coterminal angle first, because that angle right there may be any number between 0 and 360. And if you start with a negative angle, remember, it could be any number between 0 and negative 360, in which case you'd have to add a full rotation back. But I know it's also the reference angle simply because of the size and the sign of that angle. So 54 degrees lands in which quadrant? Quadrant 1. Okay, so it's going to be somewhere right here. And we'll call that the coterminal angle, which is 54 degrees. Now, it just so happens in this case that to find the reference angle, which remember is always what type of angle? A negative obtuse angle? Positive acute. It's always going to be the measure of rotation between the terminal ray and the closest x-axis. So remember, if your angle terminates in quadrant 1, it's also going to be the reference angle. And so there you go. Now, just some extra types of problems here. If your angle terminated over here in quadrant 2, let's say this was the coterminal angle, how would you find the reference angle? Good. The reference angle would be right here. So we need to subtract the coterminal angle from 180. So it would be 180 degrees minus the coterminal angle. Good. All right. If your coterminal angle landed in quadrant, what would be the next quadrant? Quadrant 3. Let's say that was your coterminal angle. How would you then find the reference angle? Would you work off 270? 270 is the y-axis. Would you work off 360? That's not the closest x-axis. You're trying to figure out what this little measure is right there. You've gone past 180, haven't you? So now the coterminal angle is bigger, and you want to know by exactly how much you've gone past 180, so you would do the coterminal angle minus 180. Remember, you're always working off the x-axis, not the y-axis. So that's how you would do that. And then if it terminated in the 4th quadrant, just going through the last possible scenario here, if that was your coterminal angle, then how would you find the reference angle, which would be this angle right here? Now we're stopping just short of a full rotation, and we want to know by exactly how much we're short of a full rotation, so it would be 360 minus the coterminal angle. So essentially, once you find that coterminal angle, it's going to terminate in one of those four quadrants. The reference angle then, the picture should tell you exactly how to find the reference angle. You work off of the x-axis. Okay. Let's do one last one here real quickly, and we'll call this a bonus warm-up since we've had 3 days off. A bonus warm-up. And I'll give you 1 minute to do this. I'm going to ask you to do the same thing we're going to do on the quiz. I'm going to give you an angle like negative 57632.178 degrees. And I want you to find essentially the coterminal angle that's between 0 and 360. And then I want you to find the reference angle. Okay? The reference angle. This will be similar to your quiz tomorrow. Keep in mind that we're starting with a negative angle. Bonus warm-up. No additional charge. Uh-oh. Luckily, it's your non-math hand. Yep. Horseplay? No. No. Football. Negative 57632.178. Remember, when you're finding the coterminal angle here, there's one extra step you take after you get rid of the full rotations. All right, see how you did. Step one, get it into your calculator correctly, and if it's negative, go ahead and keep the negative there. That way you're not going to forget that it's negative. 57632.178. No special significance to that number that I know of. We're in degrees, so I'm going to divide by 360. And again, I'm writing this down on my paper, but I'm not doing it for this example. So it's negative 160. And notice that we got some decimals there. So because it's negative rotations, to get rid of the whole number, I add back the full rotations. And I get that right there. That's one way to do it. And that's a negative fraction of a rotation. So if you multiply that by 360, you get negative 32.178. Now this angle is coterminal with the angle that we want. But if you notice, the question is specifically asking you to find the coterminal angle that lives between 0 and 360. So it has to be positive. So the last little step you have to do here is just go one more rotation in the positive direction by adding 360 degrees to it, and you get 327.822. So that would be the answer to the coterminal angle. That's between 0 and 360. Theta coterminal is 327.822 degrees. Okay, and then from there, we need to find the reference angle, which maybe you already know the answer. If you can figure out where this angle terminates, negative 327 terminates down here in quadrant 4. So the reference angle is going to be the measure of rotation between that terminal ray and the positive x-axis, which is just short of a full rotation. So the reference angle should be, as we already said, 360 minus that angle. And so if you let the calculator store the number, 360 minus the answer, second negative, you get the positive version of that coterminal angle, 32.178. So all of those coterminal angles that live at that same terminal ray, regardless of how big or how small, they have the exact same reference angle of 32.178. Okay, and one last thing. If I needed to convert that to degrees, minutes, seconds, from there I could just take the answer and then just hit alpha or second, angle, which is your apps, and hit number 4 at this point and convert it to degrees, minutes, seconds. We don't really work with degrees, minutes, seconds, so I probably may or may not ask you to do that on a quiz. But if I did at this point, you wouldn't have to show me the steps because we've already quizzed over that. All right, everyone warm? All right, well, let's jump to the notes then. We discussed another way last Friday, which was, wow, an eternity ago, it seems like, to measure an angle. And it was a unitless measure of rotation known as the what? The radian. And the definition for the radian, and this is pretty important, the definition of the radian is the following. Theta in radians is going to be the ratio of S to R, where S is the what? Do you remember? It's not real intuitive. S for arc length. Arc length. There's no S in it. Divided by the radius of the circle. So just quickly to recap, if I were to take the radius of any circle, regardless of how big or small, and wrap that length of the radius right here, let me make it a little bit bigger. If I were to take that radius right here and wrap it around the circumference, one radius length, that line that goes back to the center of the circle called the central angle, they would have a measure of 1 radian. And again, the S would be the arc length, and it's measured in the same units as the radius. So the ratio would be feet to feet, which divides out, and we get the angle measure. Now notice that it's irrespective of the size of the circle. We didn't talk about this, but if I made my radius bigger, what's going to happen to the circumference? It's also going to get bigger. And because they are linearly related to each other, direct proportion, then the scale factor divides out. Okay, so there would be my new radius. And if I wrap that length around 1 unit, it's going to be a larger arc length. But if I draw that line straight back, guess what? It's going to be at the exact same place. The scale factors divide out as well. So that's what's nice about it. It doesn't matter how big or how small the circle, the radian is always going to be the same. And of course, how many radians are there in a full rotation? Yeah, there's about 6.28, also known as 2 pi. So 1 rotation is equal to 360 degrees, which now we know is equal to 2 pi radians. And we leave it in terms of pi because it's exact. So that gives us our conversion factor. If we divide everything through by 2, we get 180 degrees equals 2 pi, or I'm sorry, 180 degrees equals pi radians, and that becomes our conversion factor. Okay, so a conversion factor, when you use dimensional analysis, it's an equivalent ratio to 1. It's not equal to 1, but it's equivalent to 1, so you can use it as long as your units divide out. You know you're doing it correctly, and if the units you want to appear are in the numerator and everything else works out, you know, it's kind of a check on your process. All right, so we were going through here and figuring out what the radian measure of some common degree angles are, and now we're going to go the other way. All right, so here we go. Convert the following angles from radians to decimal degrees. Example 9. 5 pi fourths. Now, before we convert it to degrees, I want you to start thinking in terms of radians, which is going to be a little bit novel for you, because you're going to have to start thinking in terms of pi as well. Remember that a half rotation over here is pi radians. A half rotation is 1 full pi, okay? Which is kind of counterintuitive, right? Because pies, if you eat a pie, right, they're baked in round dishes, and 1 pi is round. But on the circle, a half pi, or a half circle is 1 pi. So if we're looking at the ratio 5 pi fourths, that's the same as 5 fourths pi. 5 fourths is the same as 1.25, yes? So we're going to be going a full pi, 1 full pi, plus a smidgen of another, right? A quarter of another. So which quadrant should 5 pi fourths terminate in? It should terminate in quadrant 3. Good. Whenever this ratio, 5 fourths, is bigger than 1, just bigger than 1, it's going to terminate in quadrant 3. So I know that it terminates right there, 5 pi fourths. Now the question is, what is that in degrees? Well, 5 pi fourths is one that you're going to memorize soon enough, but if you want to know exactly how many degrees it is, you could convert it. What are the units on radians? Nothing. Good. But you can write rads in the numerator and rads in the denominator if you want something to divide out. And then, of course, we'd have degree. The degrubble would be up there. And what's the conversion? 180 over pi. Now, notice if we leave pi visible, it's great. Your pi's divide out. And then a fourth of 180 is what? 45? And what's 45 times 5? Should be 225. Or we're going 45 past 180. You can also think of it as a multiple of pi fourths. That's another way you can think about it. Let's look at it in that respect. Because we looked at pi fourths last time. Pi fourths is equivalent to 45 degrees. So if you want to count by pi fourths, you got 1 pi fourths. This would be 2 pi fourths, 3 pi fourths. 4 pi fourths, of course, would be pi, right? And then one more would be 5 pi fourths. So you're partitioning the circle up, and you end up down there with 45 degrees past 180. All right, so at any rate, it's 225. What would be the reference angle here? 45 or what in radians? Yeah, good. The reference angle would be pi fourths, which is 45 degrees. 45 degrees is pi fourths radians, okay? All right, here we got 11 pi 6. Which quadrant is that going to terminate in? Fourth. Good. All the way around is 2 pi. And if you have 2 pi's and you cut each pi into 6 pieces, well, you got yourself 12 pieces there, don't you? You can always think of 2 pi in terms of whatever the denominator is. So 2 pi is the same as 12 pi 6. We're going 11 pi 6. So we're rotating just shy of a full rotation by a sixth of pi. Okay? So the reference angle, we can actually get that first. What would the reference angle be in radians? 30 degrees or how many radians? Pi 6 or a sixth of pi, right? If one full rotation is 12 pi 6 and we're going all the way to 11, we just need one more pi 6 to make a full rotation. So you could do it one of two ways. You can realize that pi 6 is the same as 30 degrees. They're equivalent. And if you're stopping 30 degrees short of 360, then that angle should be 330. Or you can convert it by multiplying by 180 over pi. Either way, your pi's divide out. 180 divided by 6. Remember, you go small before you go big. 180 divided by 6 is 30, and 30 times 11 is 330. 11 pi 6 is going to be another one you're going to memorize. So it's equivalent to 330 degrees. All right, 2 pi thirds. In which quadrant does 2 pi thirds terminate? Let's see, 2/3 is just smaller than 1, isn't it? So we're going to land just short of a pi, which is at 180. So it should be over here. What is that going to be in degrees? Well, let's go ahead and convert it. There's two ways to think about it. If you flat out just don't know, just multiply by the conversion factor. Your pi's divide out. And, of course, then you get 180 divided by 3, which is 60. 60 times 2 is 120. Okay? What would the reference angle be? It's this one right here. What would the reference angle be? 60 degrees, or in radians? Pi thirds. Good. If getting all the way to the x-axis is pi, that's the same as 3 pi thirds, correct? Pi is the same as 3 pi thirds. So if I'm rotating all the way to 2 pi thirds, all I need to do to get to 3 pi thirds is go one more pi thirds. So the reference angle would be pi thirds. And, of course, we learned on Friday that pi thirds is 60 degrees. So you can also count by pi thirds. There's 1 pi thirds. This would be 2 pi thirds. You'd have 3 pi thirds down here. This would be 4 pi thirds, 5 pi thirds, and 6 pi thirds would be a full rotation. Okay? So everything partitions up pretty nicely. 7 pi fifths. This one's kind of funky. Let's figure out where this guy terminates first. 7 fifths, is that bigger than 1 or less than 1? It's bigger than 1. So if this is pi over here, that's going to be the same as 5 pi fifths. Agreed? Now the question is, if I go past there, am I going past pi enough to get past 270? Well, here's a real quick way to tell. If that's 5 pi fifths, this is pi halves. What's half of 5? 2.5. So that would be the same as 2.5 pi fifths. And now you're counting by 90 degrees, or 2.5 pi fifths. So that'd be 2.5 plus 2.5 is 5. What's 5 plus 2.5? That would be 7.5 pi fifths. And if you went another 2.5, you'd get 10 pi fifths. So you can always call pi 7 pi sevenths, 8 pi eighths, whatever you need to, and then half of that numerator is going to be up here at 90. And then you have your quarter cycle counting interval. You're counting by quadrants now. So if you know down here at 270 is 7.5, and you're only going 7, you stop just short of 7.5. You're down here somewhere, right? That's 7 pi fifths. So you know you're going to be in quadrant 3. Now before we figure out what that is in degrees, here's my question to you. Here's the reference angle right there. It's the measure between the closest x-axis, which is 180 or pi, and 7 pi fifths. What is the reference angle? 0.5? Remember, it's easy to call it 0.5 because notice the terminal ray is only a half of a pi fifths away from the y-axis. But the reference angle always measures the rotation between the terminal ray and the closest what axis? X-axis. So if the x-axis that's closest is 5 pi fifths, and I've rotated past it to 7 pi fifths, the reference angle is the amount of that over rotation, which is how much? 2 pi fifths. So notice if you could draw the picture, you have your answer right there. You'll know whether to subtract from 180 or subtract from pi, or to do that number minus pi. It'll tell you what to do. 5 pi fifths plus another 2 gets you to 7. So that's the reference angle, 2 pi fifths. All right, let's figure out what 7 pi fifths is in degrees. I know it's got to be between 180 and 270. We'll multiply by what to convert it? 180 over pi. Good. And your pi's divide out. And you're left with, let's see, let's divide first. What is 180 divided by 5? 36. And then 7 times 36 would be 252. So 252. And of course, you can do that with your calculator as well. Once your pi's divide out, don't type pi into your calculator because it's irrational. Realize they divide out. Just go to your calculator, 7 times 180 divided by 5, hit enter, and it'll give you a decimal. And then, of course, all you have to do to convert it is what? Math, enter, enter. It'll convert it back to a fraction. Or it'll give you 252 in this case. Sorry, your pi's divide out. All right, last one here, 1.346. Is that an angle? It is an angle. Is it in degrees or radians? How do you know it's in radians and not degrees? There's no degrubble, okay? If there's no degrubble and it's in the context of an angle, it's got to be in radians. So if you want to put rad there, that's great. Just like up here on Friday, it looked like 5 pi fourths radians, but we knew it wasn't in radians because it had a degrubble. So in the context of an angle, whether or not there's a degrubble means is it in degrees or is it in radians? Very important. Now notice this one's different because there's no pi visible. There doesn't have to be a pi that's visible. We want to know what 1.346 radians is. So that means basically, I don't want to do it that way. We're going to take the radius of a circle, and we're going to rotate around that circle one full length of the radius, which might be right here, plus a smidgen more, about a third of another. And that's going to be the angle we want. It should be in quadrant 1, maybe approaching 90 degrees. Okay? Let's go ahead and figure that out. 1.346. I'll put rad there. What do we multiply by to convert it? Pi over 180 or 180 over pi? If you multiply by pi over 180, look what happens. If you put rads there as a description, if you multiply straight across, look what your units are going to become. You're going to get radians squared per degree. Radians squared per degree. Is that right? No, it's not right. So that's the benefit of stoichiometry. Your units have to make sense. So I guess it's got to be 180 over pi radians. Now, if you want to write the rad, because there's no pi to divide out, you're left with degrees. Does that make sense? Degrees? Makes perfect sense. Now, in this case, because there's no pi to divide out, you're going to end up typing pi into your calculator, which is fine. So here we go, 1.346. We'll just say times 180, and then we'll divide by pi. So get pi in your answer, and of course, it's not a terminating decimal, so one more time, how many decimals are you responsible for reporting? 3. And you can round or truncate. Either way, if you round or truncate, it becomes 77.120. Now, if that last decimal is a 0, do you really need to write it? Yes. Okay, because it's not a terminating 0. There are numbers after it that aren't 0, so it's part of the accuracy of the number. So don't leave that trailing 0 off. Okay, so that did end up being in quadrant 1. All right, I'm kind of curious here very quickly. What is the angle measure of 1 radian? Do that very quickly. I'm kind of curious. 1 radian is how many degrees? If I took any circle, I took its radius, and I wrapped it around the circumference, and then I went a straight beeline towards the origin of the circle, how many degrees would that subtend? 1 radian. We know 180 degrees is pi radians, but it's kind of nice to know approximately what 1 radian is. Nope, another pooping dog. No mystery why the grass is so green. What'd y'all get? 57 point, one more time? 295. I like that. Again, all you have to do is multiply by 180 over pi, which is really just 180 divided by pi. So it's about 57.1295. Not quite 60 degrees. That's kind of something that, to be culturally literate, you should kind of have a grasp on. 1 radian is a little bit less than 60 degrees. 60 degrees is how many radians? Pi thirds. 60 degrees is pi thirds. Good. That's one you need to know for sure. Soon enough, okay? So 1 radian is a little bit less than pi thirds radians, right? Because that's 3.14 divided by 3. Okay, questions so far? These are just converting? You remember what we did in the warm-up with the big angle in degrees? We're going to do it now with radians, okay? For each of the following angles, we're going to find the coterminal angles that live between 0 and 2 pi. This right here is another way to say the following. This is how I gave it to you in the warm-up. This is exactly the same thing. The angle has to live on the half-open interval between 0 and 2 pi. And then we're going to find the coterminal angle, and then the reference angle, all right? Now, here's the catch. We're not going to convert it to degrees first, and then work the problem in degrees and convert everything back. That's one way to do it, but that's not the way I want you to think. So, let's look at this. Our angle is theta, and is it degrees and radians? Which one, degrees or radians? It's in radians. How do you know? Not because there's pi necessarily, but because there is no degrubble. Yeah, okay. Is that going to be more than 1 rotation? Yes. So here's the way I'm going to teach you to do it. If we're partitioning our circle up into sevenths, right, 1 rotation is going to be how many pi sevenths? Of course, it's going to be 2 pi, but how many pi sevenths? Well, 7 pi sevenths, remember, would be half rotation. It would be twice the denominator. Remember, it's 2 pi. So 1 full rotation is always twice the denominator. Because what's 14 divided by 7? 2. 1 full rotation is always twice the denominator. Got it? 1 full rotation is always twice the denominator. Okay, so here's what we're going to do. I basically have 46365 pi sevenths. That's another way to write it. And I really just want to focus on this number there. Because I know if it takes 14 pi sevenths to make 1 full rotation, and I have 46365 of them, I just need to figure out how many times 14 goes into 46365. I don't need to worry about the pi sevenths part. So here's what we're going to do in general. We're going to take the numerator, 46365, and we're going to divide it by, not the denominator, but twice the denominator, because that's going to tell us how many of those partitions, in this case pi sevenths, are in one rotation. So the numerator divided by 2 times the denominator. And it should give us the same result in terms of the number of rotations. 46365 divided by 14. That means I got 3311.785 ... rotations. Okay? Now, the same thing we're going to do with, or we did with degrees, we're going to do right here with radians. I don't care about the full rotations. So I'm going to go ahead and subtract the full rotations. And notice when I put ... that means that we're using the live number. We're letting the calculator store those decimals in all their glory. So if I now subtract the full rotations, just like we did with degrees, notice you get more decimals appear. That's awesome. It was storing them for us. That now is the fraction of a rotation. We previously remultiplied that by 360, but we don't remultiply that by 360. We remultiply that by what? Not 2 pi. You always remultiply by the number you divided by. It's like a temporary thing. Remember, we divided by 360, and then we multiplied by 360. Same thing here. If we divide by 14, we get rid of the full rotations, and we remultiply by 14. And what that's going to do, it's going to give us our new numerator for our pi sevenths in this case. Now, new numerator is kind of hard to say. You got to be careful not to get stuck, right? New numerator. All right, here we go. Ready? Times 14. And we get what? 11. Now, is 11 our answer? No. 11 is our new coefficient of pi sevenths. So we end up with 11 pi sevenths. And that is your what angle? Coterminal. When you do this process, it'll always give you the coterminal angle. It may or may not be the reference angle. It's only going to be the reference angle if it's positive and acute. Well, to be an acute angle in radians, the angle has to be between 0 radians and what? No, an acute angle is less than 90 degrees. 90 degrees is how many radians? A half pi or pi halves. So is 11 pi sevenths less than pi halves? No. So this is the coterminal angle. Okay, see what we did there? Real quick recap. We take the coefficient of pi in the numerator, we divide it by twice the denominator, subtract out the full rotations, remultiply by that same number we divided by, which is always going to be different. That gives you your new coefficient of pi sevenths in this case. That's always the coterminal angle. From here, you then figure out where 11 pi sevenths lives. And this is so much fun. Because pi is over here, which is how many pi sevenths? 7, right? Take a pi, cut it into 7 pieces. You have 7 pi sevenths. What's half of 7? 3.5. So if you do that, then you take half the numerator, and you're up here at 90 degrees. And so now all you have to do as you go from one axis to the next is just keep adding 3.5. Okay, so here we go. This is 3.5 pi sevenths plus another 3.5 gives me 7. What's 7 plus 3.5? 10.5 pi sevenths. And if I add another 3.5 to 10.5, I end up with 14 pi sevenths. So you can always partition a circle in terms of full multiples of pi just by starting with pi, taking half, and then you get your essentially your 90 degrees, your quarter cycle counting interval. And now that you have it all labeled, it's super easy to figure out where 11 pi sevenths lives, isn't it? We're going to start here and rotate in which direction, clockwise or counterclockwise? Counterclockwise, because it's positive. And we're going to go all the way to 10.5 plus a smidgen more, yeah? That's 11 pi sevenths. Go us. And now that you have it drawn, it is super easy to determine what the reference angle is. If you want to draw it first, Remember, it's the measure of rotation between the terminal ray and the closest x-axis, which is 14 pi sevenths, yes? So, if I'm at 11 pi sevenths and I need to get to 14 pi sevenths, all I got to do is rotate how much more? 3 pi sevenths. So if you want to show the math, it's 14 pi sevenths minus 11 pi sevenths, which equals 3 pi sevenths. There you go. So 11 pi sevenths and that first angle we started with, they're not the same angle, but they terminate at the same place. And they have the exact same reference angle, 3 pi sevenths. Okay, you got that process down? Kind of fun. Kind of fun. All right, let's do another one. I got negative 789,637 pi 11ths. Woo, what a fun one. Notice that that is a negative angle. Kind of sneaky, right? All right, here we go. I want to figure out how many full rotations that is. We're counting by pi 11ths here, right? That's our partition. I need to take the numerator, which is the coefficient, and I need to see how many pi 11ths are in full rotation. How many pi 11ths are in a full rotation? 22. So if you take the coefficient with the negative there, remember, and divide by twice the denominator, that's going to tell you how many full rotations. If you divide by the denominator, you are only going to be figuring out the number of half rotations, which is not going to necessarily give you the correct answer. So you got to be careful. 789,637 with a negative. We'll divide it by 22. So we're getting lots of rotations. Negative 35892.5909, 59091, ... Because it's negative now, we have to add back the full rotations, 35892, and you should see more decimals appear. 0.59090, it looks like a repeating decimal. And it's still negative, notice. Now I need to take that and remultiply. You always remultiply by the same number you divided by, which in this case is 22. Okay, so keep that in mind. For radians, it's going to change every time. For degrees, it's always 360. And you end up with negative 13. Negative 13, then, is not your answer, but it becomes your new coefficient of pi 11ths. So a coterminal angle is negative 13 pi 11ths. Now, if this were a multiple choice question, guess what answer choice A would be? It would be positive 13 pi 11ths. And that would be wrong. Even though that is coterminal, remember, this is asking us to find the coterminal angle that is strictly between 0 and 2 pi. So, just like we did with degrees, if we had a negative coterminal angle, we added one full rotation to it, yes? All I have to do is add one full rotation to this, which is how many pi 11ths? 22. So if you just add 22 pi 11ths to that answer, which is equal to one rotation, what's 22 minus 13? 9. So 9 pi 11ths is the one we want. So just remember, if it's a negative angle, you have that one extra step at the end. You add one more full rotation to it, whether it's 360, whether it's 22 pi 11ths, whether it's 14 pi 7ths, you add one full rotation. Okay, so now we have the coterminal angle. I need to figure out where 9 pi 11ths lives so I can find the reference angle. So here's that process. I like to do it like this again. I come out to pi, and I know that that's equivalent to 11 pi 11ths. If I take half of 11, that's 5.5. So up there at 90 degrees, or pi halves, that's 5.5 pi 11ths. Once you have that, you can just keep adding 5.5. So 5.5 plus 5.5 is 11. 11 plus 5.5 is 16.5 pi 11ths, and if you add another one, you get 22. So once you have it all partitioned into 11ths, now it's real easy to figure out where 9 lives. 9 goes past 5.5, but it's short of 11. So there's 9 pi 11ths. And here we go for the reference angle. The reference angle, remember, is the positive acute angle between the terminal ray and the positive x-axis. What's the reference angle? 2 pi 11ths, right? Again, if you're stopping short of the x-axis and you know you're at 9, all you got to do is get to 11, and you need to go 2 more. So if you do it like this each and every time, drawing the picture, you're going to be 100% correct every time. If you try to deviate from this, that's fine if you're clever enough and you can figure it out. But I've seen so many students not draw the picture, not do it like this, and get the wrong answer, okay? So you're going to start thinking in terms of fractions, and you're going to start thinking in terms of pi. And it's going to stretch your brain, and it's never going to go back to the original shape. And that's a good thing. Yeah. Okay, are you ready to try one on your own? Well, maybe, maybe not. Let's try that. Let's do it together. These are the last two. We'll finish them together. Notice this one is not a fraction, is it? It's a full multiple of pi. If you want to make it into a fraction, you could put it over what? 1. Okay, so now we can do the same recipe here. You take 1, 4, 9, 9, 8, 7, 6, 3, and divide it by what? 2, right? Twice the denominator. There are 2 pi in one rotation. So let's do that. 1, 4, 9, 9, 8, 7, 6, 3. Remember, we're not leaving the pi there. We're leaving the pi off. We're dividing it by twice the denominator. And then we subtract the full rotations. 7, 4, 9, 9, 3, 8, 1. And then we remultiply that by the same number we divided by, which is 2. And that's 1. So that gives you your new coefficient of pi firsts. So we end up with 1 pi firsts, also known as pi. Now, here's a quicker way to do that. If you ever have a full multiple of pi, just think about this, okay? Watch this. We start with 0. If I rotate over here, I get pi. This becomes 2 pi. This becomes 3 pi, 4 pi, 5 pi, 6 pi. You see a pattern? 7 pi, 8 pi, 9 pi. Going backwards from 0, you get negative pi, negative 2 pi, negative 3 pi, negative 4 pi. What do you notice about all the pi's on the positive x-axis? They're counting by 2, so are those. These are evens over here, and on the left side we have odds. So if you ever have full multiples of pi, any even multiple of pi is going to be coterminal with 0 and have a reference angle of 0, and any multiple of odd multiple of pi is going to be coterminal with pi and have a reference angle of 0. Okay, so that's another way to do it. Now the last one here, very quickly, there is no pi in here. So if there's no pi visible, you go back to doing what we did before. You multiply by the quantity 2 pi. You have to take out the full rotation, which is kind of like dividing by 360. 3, 6, 1, 4, 2.51. Divide it by, and here you got to put parentheses if you don't use the horizontal division bar. That's a full rotation. Again, subtract out 5, 7, 5, 2, the full rotations, and then remultiply it by 2 pi. And you end up with 1.62811. That's the coterminal angle. Y'all can start putting your calculators away. That actually terminates over here in quadrant 2, so the reference angle is going to end up being this here, which is pi minus that. Okay, so start thinking in terms of radians and get comfortable. Don't cheat yourself by converting to degrees and then converting back to radians. Force yourself to think in terms of radians. All right, we're done. The worksheet's due tomorrow. I'll have the folder in e-backpack. Remember, it's due by the start of class. I think I have it set to give you like a 3-minute grace period in case you try to turn it in as you walk in the door. All right? I'll be here at 7 if you have any questions, and we'll quiz tomorrow and start the next section. When's our test? On Friday. Today's already what? Tuesday. All right. Y'all can go. No bell. Have a great day.